All right, let's review the odd questions here. What is the difference between an observational study and an experiment? In an observational study, you just observe. Responses to it. In an experiment, you first apply a treatment, then you observe the responses. So in an observational study, we're not actually applying any treatment to it, we're just watching. In an experiment, you apply treatment and then observe. Number 3, what is the difference between a random sample and a simple random sample? In a random sample, every person has the chance to be selected. In a simple random sample, just write that SRS. Or not. Each group has a chance to be selected. So simple random sample, you break them down into groups first, and then you randomly select a group. Okay, on to number 5. Placebo is an actual treatment. Sorry if I'm a little better way to do it. Placebo is an actual treatment. Number 5 is false. That would be a fake treatment. Number 7. Using a systematic sample guarantees that members of each group within a population will be sampled. That is false. The reason that's false is because there could be a recurring pattern in the data. Oops. The reason there could be a recurring pattern is, say we're looking at people waiting to go into a movie theater. If all the guys stand on the left and we only take a systematic sample of everyone who's on the left side, then that creates a pattern where we're only looking at the guys, as opposed to males and females. Number 9. The method for selecting a stratified sample is to order a population in some way, then select the members of the population at regular intervals. That is also false. And the way to make that true is get rid of stratified and make this systematic. It's like putting all the guys on the left-hand side and then selecting the members from like every third guy. Number 11. Now we're supposed to say whether it's an observational study or an experiment. In a survey of 177,237 U.S. adults, 65% said they visited a dentist in the last 12 months. That would be an observational study. All we're doing is finding out whether they visited the dentist. We're not making them go to a dentist. That's why it's not an experiment. We had no effect on the outcome. Okay. Number 13. Studied the effect of music on driving habits. 8 drivers, 4 male and 4 female, drove 500 miles while listening to different genres of music. Now this one is kind of different because it seems like it's just an observational study. It seems like we're just checking to see what happens if they listen to different genres of music. However, most of you don't listen to different genres of music. It would be like me asking AJ to listen to country music and see how he drives. So this is most likely an experiment. Because we're changing the music and they're driving for 500 miles, listening to different types of music as they go. Okay, number 15. We're looking at an allergy drug. Pharmaceutical company wants to test the effectiveness of a new allergy drug. The company identifies 250 females aged 30 to 35 who suffer from severe allergies. The subjects are randomly assigned into 2 groups. One group is given the drug, and the other is given a placebo that looks exactly like the drug. After 6 months, the subject's symptoms are studied and compared. A. Identify the experimental units and the treatments used in this experiment. So, the experimental units are females, ages 30 to 35. That's what we're experimenting on. The treatments are a drug and a placebo. Part B. Identify a potential problem with the experimental design being used and suggest a way to improve it. One problem is all subjects are females. Could improve by adding males ages 30 to 35. How could this experiment be designed to be double-blind? Since the pills look exactly alike, we could have, as you can tell, I'm not an English teacher, could has an L in it. We could have researchers give the pills, without knowing which one is real until the end. All right, number 17. It says use the sixth row of table 1 and appendix B to generate 12 random numbers between 1 and 99. Guess what? I didn't give you the table 1 and appendix B. So it'd be hard to do this. But you could have used the one that's in your notes. So if you pull your notes up, easiest way to do it would be to say, okay, I'm going to take the sixth row of the table and then just do the first two numbers of each one of the random numbers sets. Like there's 6 numbers in the set, so you just pick the first two. Starting in that sixth row, go across and choose the first two from each. Since there's not 12 columns, you would then go down to the 7th row, choose the first 2 numbers from each of those. Number 19. Number 19. Again, I screwed up here because we don't have the technology to generate the random numbers. We actually do. You can do it on your graphing calculator. There's a thing called the random number generator. Since there's really no way for me to show you how to do that on a calculator, I can't really ask you to be able to do that. Number 21. Kind of the same thing. I can't ask you to do it because I can't show you how to use the random number generator. Or I could have. Maybe I'll make that another video. But those are pretty simple. Actually, I will put it at the end of this video so you know how to do numbers 19 and 21. Okay, for this one, using random digit down, researchers call 1,400 people and ask what obstacles, such as childcare, keep them from exercising. This will be a simple random sample. These people is just randomly chosen. There's no way that they did anything in order to pick those people. It was completely random. Number 25, questioning students as they leave the university library. Researcher asked 358 students about their drinking habits. This is a convenience sample. The researcher isn't going out of his way to ask anybody else, just asking people leaving the library. For the first one, by the way, there was no potential bias as we could see, just from simple random sample. For the second one here, convenience sample, the kids are leaving the library. Gives you an indication that they're at least there to study. So most of the students who are leaving the library probably aren't going to say, oh, I drink all week long. In order to do this, they probably would have had a better chance if they just pulled student ID numbers. Chosen at random, 580 customers at a car dealership are contacted and asked their opinions of the service they received. This is also a simple random sample. They're just pulling regular people completely at random. Number 29. Soybeans are planted on a 48-acre field. The field is divided into 1-acre subplots. A sample is taken from each subplot to estimate the harvest. This is a stratified sampling. The reason it's stratified is it's broken into 1-acre plots, which are the different strata. Each 1-acre plot is its own strata. And then we're taking a sample from each one of those. Okay, number 31. The average age of the 115 residents of a retirement community. Would this be a census or sampling? In this case, it would be a census. We're probably going to just go through all 115 residents in the retirement community. So that would be census because we're doing all of them. Number 33. This is recognizing a bias question. Why does eating whole grain foods improve your health? The reason that this is a biased question is it's automatically assuming that whole grain foods improve your health. So this would be biased. So then it says suggest better wording. Your better wording could be if whole grain foods improve your health, what is the reasoning? Number 35. How much do you exercise during an average week? This is a non-biased question. Doesn't assume that you exercise at all. Doesn't try to guilt you into exercising. So it's non-biased. Number 37. Again, you did not have page 16. So you can't really answer that question. Number 39, open and closed questions. Okay, looking at 39, it says list an advantage and a disadvantage of each question. For an open question, one of the advantages would be that we could get a lot more responses. And then we could check and see how many people's responses are similar to each other's. We're not giving them what their answer should be. A disadvantage of that is that there could be a lot of different responses. So that we might not get an answer at all. So everyone might have their own different answer to it, which means that the study didn't really do anything for us. It was just a bunch of different random answers. An advantage of a closed question is that we could get more ideas, or everyone's ideas all together in a group. So if we only have four different options for them to answer, or 3 different options in this case, by having only 3 different options, we could get everybody's ideas kind of organized. They would either pick 1, 2, or 3. Number 41, not going to have you do that. But I am going to have a lesson about articles and statistical studies and the way that newspapers and magazines, news programs all try to skew the data in order to make it fit whatever they're trying to say. All right, let's go back to the random number generator. Okay, on questions 19 and 21, what we can do is, like for number 19, it just wants 15 numbers between 1 and 150. So all you do is you go into your calculator, go math, and then I always push this direction to probability, and then number 5. So this is saying it's going to give you a random integer that's between 1 and 150. So you do 1, comma, 150, comma, and then the total numbers that you want generated. And now it's generated 15 numbers. So we have 141, 17, 1, 83, 129, 147, 42, 42, 19, 8, 109, 264, 47, and 146. Now your numbers definitely will not be the same as mine because your calculator is generating a random number for each one of them. So your number should not be the same as mine. As a matter of fact, if we ran the same thing again, it should generate 15 completely different numbers. Okay? Number 21. So now taking that principle, how would we use it for number 21? Well, there's 18 different people, right? And so we just want to choose 9 for the 9 for this treatment group. So in order to do the 9, we would do random integer again. And 1 to 18. And then 9. And then we would just assign each number in the order that the names are listed out. So number 6, person number 6, 1, 2, 3, 4, 5, 6, that would be Adam. So Adam, Maria, Connie, Lucy, Carlos, Mike, Ron. I feel like you get the point. Judy, and Bridget would be our 9 people. Now that's just for mine. Yours again will generate its own. Alright, that's the end of this lesson. Go ahead and do the even numbers for homework.